Alright, a very good afternoon, Ichihata. My name is Steve Nicholas, and I'm a lucky student Suresh with the matric number of 09DEM20F1019, followed by two of my group mates who are Taranvi Singh and Gaushi Ganai. For today's presentation, we are going to present to you our case study of our Programmable Logic Controller PLC subject. So I'll be explaining or presenting the part of the introduction of our group members, followed by the Autonomous Distributing and Counting Factory, which is the name of our factory, the objective of our factory, as well as the total input and output devices in the system. So let's start with the objective. So as the slide has already been stated, the name of our factory is called the Autonomous Distributing and Counting Factory, where it distributes the boxes and leads evenly, and it also able to count the number of boxes and leads that are flowing through the factory that we have made here. The objective of our factory, number one, is to able to create an autonomous system using a programmable logic controller, PLC, to provide a facility that can sort objects such as boxes and lids according to their colors, which in this case, blue and green, accurately, and also enhancing the efficiency in distributing and counting by signifying the workers, the number of boxes and leads accumulated. So these are our objective of the factory. Now, next would be the total input and output devices in this system. As you can see in this slide, this is an overview of our total input and output. The left you can see are the inputs, and the right, as you can see, are the outputs. For started, the basics would be the start and stop input, followed by the diffuse sensor in order to count the items. Okay, another diffuse sensor in order to detect the presence. Okay, and also differentiate the colors of the lid. Okay, a diffuse sensor for the boxes, and also another diffuse sensor for the lid. A vision sensor, okay, this is in IO.0, IO.1, IO.2, IO.3, IO.4, IO.5, IO.6, all the way until I1.5. Okay, we have diffuse sensor for the lids. The reset one, the reset input, the emergency stop input, the vision sensor, this is for the blue lids. Okay, the vision sensor is for the green lids. All right, the vision sensor to number or to count the total lids for blue. All right, and the diffuse sensor for numbering the amount of boxes. Followed by the output, as you can see on the right hand side, there's the curved belt conveyor for the boxes, the belt conveyor, the pop-up wheel sorter. This will actually help in rotating the wheels in order for it to divide which chamber shall it actually go. Okay, whether is it the box chamber or the lid chamber. Then this particular process will be simulated and shown by my friend Taranvi later. The belt conveyor, the pop-up wheel sorter, the belt conveyor again, the pivot arm sorter. This is very helpful in also navigating and guiding the items that are on the conveyor. All right, and also the warning light. This warning light is able to signify workers until the amount of or the number of boxes or leads able to be achieved. So if we were to have like just say 30 boxes, so once it has already detected that there's 30 boxes and 30 leads accumulated, then there'll be a warning light which signifies workers that that is the perfect number that they need to keep and continue with the next batch. So that is all for my part. I would like to pass this time to Taran B for his part in explaining the step operation. Okay, and also the working principle of the operator. Thank you so much for watching, sir, and I'll see you in the next video.
Salam sejahtera. Saya Taranvi Singh dari kelas DM4A dalam muka masa saya 09DM20F139. So hari ini saya akan menerangkan bahagian case study, bahagian how many operators dan state of operation. So ada operation dekat sini ada 4, start, reset, emergency stop dan stop button. Operation state dia adalah kita akan tekan button start, kotak akan bergerak, selepas itu lead akan bergerak, kotak akan dikira, kotak akan dikeluarkan mengambil output conveyor, lead akan dikira, lead akan dikeluarkan, Kita sentuh secara as output, dan green and blue lead akan biru dan hijau lead tu akan dipisahkan lah, diasingkan secara yang lain lah. So, kita akan tengok lebih lanjut dekat PTIO. Okay, so PTIO ni kita akan tengok operasi yang apa yang berlaku. Okay, okay, kita stop dulu. Okay, ni tadi belum di stop. Okay, kita akan stop, kita akan resetkan. So ni adalah keadaan asal lah. Okay, ni adalah keadaan asal. So kiranya ini keadaan asal. Okay, ada kotak dan ada lead. So kotak tu akan masuk sini dan keluar sini, dan lead ni akan masuk sini dan keluar sini. So lead ni akan, yang hijau akan turun ke bawah sini, dan yang biru akan teruskan perjalanan. Yang hijau akan ditolak ke kanan bahagian sini, kanan bahagian sini, dan biru akan ke sini. Okay, so tu dia punya secara umum. So kita ada 3 display, which is jumlah kotak. Okay, jumlah kotak, jumlah lead biru, dan juga total production. Total production ni adalah lead biru, lead hijau, dan juga jumlah kotak lah semua. So bila kita nak kira jumlah lead hijau, so total production ni kita kena tolak dengan jumlah biru dan jumlah kotak. Okay, so itu kita nak sedikit matematik untuk mengira. Okay, so kita akan start button, tengok operasi. Kotak dan lead akan bergerak secara bergilir-gilir. Kotak, lead, kotak, lead, kotak, lead. Okay, okay, kotak, lead. So tu tadi sangkut kotak dan lead sini. Lead akan masuk sini, lead hijau akan masuk sini, lead warna biru akan masuk sebelah sini, lead hijau akan masuk sebelah sini, lead biru akan teruskan perjalanan. Setiap 20, setiap total production 20, lampu akan menyala untuk memberi isyarat kepada pekerja bahawa barang-barang boleh disusun. Bila dia akan menyala, bila total production 20, so maksudnya dia bergerak secara bergilir-gilir. So maksudnya di sini kotak akan ada 10, dan jumlah hijau dan biru kedua-duanya bila campur akan ada 10. So di situ lampu akan menyala. So sekarang ni dah 35, 36, 37, 38, 9, 40, dia akan menyala. So bila kita nak habis kerja dah, kita nak stop. Okay, kita stop, kita hold sebanyak 3 saat macam tu. Lepas tu kita tengok okay, berapa kita dah total production 47, biru ada 10, jumlah kotak ada 24. So kiranya 24 sama ni adalah 34. So 34 ada 6 campur 7, ada 13 kotak hijau. Okay, 13 jumlah kotak hijau yang telah dikeluarkan, 10 kotak biru, 24 kotak biasa, kotak yang ni. So lead hijau 14, 13 sorry, lead biru 10. So total dia 47 lah semua. So kita nak balik dah, kita just tekan reset. Okay, matikan semua proses, dia akan matikan. Dan untuk safety kita tekan emergency button ni, kita just tekan. Okay, so kiranya apa-apa butang pun dia tekan, dia tak akan function. Dia tak akan function apa-apa. So kira macam safety button lah, safety button. So bila kita nak start, kita balik, kita okay, tak balik, sebalik. Okay, dan kita release kan, kira lah mula seperti biasa. Jadi kalau kita ada emergency, kita just boleh tekan emergency lah. So bila dia emergency, dia berhenti. Okay, ni berhenti, semua berhenti. Okay, ini terdapat serpihan lebih ni tadi. Okay, dekat sini dia ada, dia dah berhenti segala-galanya. Okay, kita akan reset kan. Bila kita dah tekan emergency, kita perlu reset supaya operasi tu dia tahu apa nak buat. So dia dah berhenti tengah-tengah. So ni dah 5, so kita kira 5 production untuk hari ni. Kita kena catat lah, kita kena ingat. Kita reset dan kita start. Okay. Okay. So itu sahaja. Dan nak berhentikan, kita hold stop button untuk 3 saat macam tu. Okay, di production dah keluar. Okay, telah dikira, telah keluar, iaitu 10 untuk production kita hari ni. Okay, so contoh kita nak kita dah reset, kita dah habis kerja, kita reset. So lampu ni akan menyala setiap 20, setiap 20 total production. So kiranya bila 20, 40, 60, dia akan menyala lah. Macam seperti mana kita tengok tadi, kita bersama je. Kita tunggu sehingga total production 20. Kita tengok lampu dia menyala macam mana. Lampu dia akan menyala sebanyak 5 saat. 17, 18, 19, 20. Okay, lampu dia menyala selepas 20. So kira isyarat telah dibari lah. So kira untuk pekerja boleh datang sini untuk mengemas lah. Mengemas untuk delivery. Picking. Untuk pick barang-barang ni untuk delivery. So bila kita nak stop, okay, dah cukup kita nak stop. Okay, kita nak stop. Kita hold sebanyak 3 saat. Okay, selepas kita hold sebanyak 3 saat tadi, kotak tadi dah gerak. So kita dah stop lah. Bila kita dah stop, kita just total production hari ni 31. Okay, kita stop, kita reset, semua akan mati. Kita tekan button sini untuk safety. So kira tekan button apa-apa pun, dia tak akan start. Okay, apa tak ada function. So kita dah boleh balik lah. Okay, so itu sajalah untuk sistem yang telah saya buat. Ada safety button, emergency button ni. Kita just tekan safety button ni sebagai safety button juga. So kiranya bila kita tidak pasti, bila ada orang cuba nak tekan apa semua, start ni memang tak boleh lah. Budak-budak tekan ke, datang malam-malam apa semua. Dalam kilang ni apa-apa sebagai safety kita tak boleh tekan dah. Kalau kita tak nak guna sini, kita just tekan stop, emergency stop button. So itu sahajalah daripada saya. Sekian, terima kasih. Seterusnya tentangkan untuk estimate cost dan juga advantages oleh Gaussian. Sebelum dibentang di Gaussian, so ini adalah frame yang telah didapatkan untuk menghasilkan produk operasi tersebut. Okay. Diagramnya kita dapat total sebanyak input untuk operasi tersebut. So ada counter, ada penggunaan timer off dan timer on tersebut. Okay. Bukan counter, timer. Okay. So itu sebelum itu sedikit driver. So sekian daripada saya. Seterusnya akan show.
A very good day to Inche Hata. My name is Kaushingana Lucky B. Keswan and I am from class DEM4A and my metric number is 09DEM20F1027 and I am the third presenter for the PLC case study in my group. So first of all, my part of the presentation is explaining about the estimated cost of the automation system that we have built, and second, the advantages of the automation system. So without any delay, let's start with the estimated cost. So first of all, these are the components and machine that we have used to build the automation system. So which is the belt conveyor, curved belt conveyor, pivot arm sorter, curved conveyor, pop-up wheel sorter, bracket and column, capacitive sensor, diffuse sensor, vision sensor, electro switchboard, warning light, and finally the warning light. Okay. So we have also give the quantity of each component and machines, and finally at the third, the price for each quantity. So first of all, let's start. The belt conveyor, we have used 4 quantity, and the total price based on now current economy before the 1st July started is RM 880. So next, for the curve belt conveyor, which is the quantity is 1, and the price is 4,400 for only one curve belt conveyor. Okay, next, pivot arm sorter that we have used to separate the green and blue leads. So the quantity is 1, and the price for the one pivot arm sorter is 700. So next, the curved conveyor. The quantity is 2 and the price of each is 500 and totally is 1000. So next, the pop-up wheel sorter. The quantity is 2 and all together is 600. And for the bracket and column, there is 2, quantity is 2 and the price is 400. So for the capacitive sensor, we have used only 1 and the price is 75 ringgit. And for the diffuse sensor, is the sensor we have used most in our automation system. which is the quantity is 6 and the total price is quite cheap compared to other, which is 52 ringgit, although we have used 6 of them. So next, for the vision sensor, the quantity is 2 and the total price is 2200 for the 2 vision sensor. And next, the electro switchboard. So the quantity is 1 and the price for it is 530. And finally, the warning light. So the quantity is 1 and the price for the warning light is Rm 85 ringgit. So all together totally is the price roughly in around 10,130 30 ringgit Malaysian. So that is the total price for the automation system components and machine that we have built. So 10,000 RM 10,130 ringgit. So the total estimated cost for the automation system. So next, let me look at the advantages of the automation system. There are 4 main advantages, which is this. First of all is less human energy needed to distribute the boxes and leads. So the first advantage of our automation system is less human energy will be needed to distribute the boxes and leads. So next, to detect the color of the leads and able to differentiate it smartly. So it will detect the color based on like blue and green, for example. It will be separate them by color wise with the help of vision sensor and the pivot arm. So from there we can see the separate the different color of green and blue leads. So third, signifying workers the total boxes and leads accumulate with the aid of the warning light. So the warning light will be alert the workers to signify the total boxes and leads that have collected in the boxes. So that it will help them to separate the number, to watch the number, and it will be easier for them to make box by box, like a dozen, like each box have 20 leads, means it will be warned after the 20 leads have collected with the warning light. So for the fourth one, save time to operate the system. Yeah, the time will be much won't be delay the workers, and it will be save their time of distributing also. And that's why that is the advantages of the automation system we have built. And also that's all from us for the advantages of our automation system that we have built. So that's all from us. Thank you for listening, sir, and have a good day. Thank you.